What's up, Aero folks? I'm here today to show you how a reaction engine works and what parts of it are to make this whole system work. I'm here with Aviation, who is a technical specialist in engine overhaul engineering. Aviation will then explain to me how the engine works, what the parts are, and how it works. Aviation, where does the whole stage begin?
So, here we basically work with reaction engines, which is what we have in mass today in aviation. Basically, engines in reaction, they move the large mass of air backwards, causing the engine itself to move forward, and this is transferred to the wings of the aircraft through attachment devices, making the aircraft move towards the forward and up or down, according to the movement of the rudders, let's say, command.
On the control surface of the aircraft.
Reaction engines, in general, depending on the model, can have 3, 4, or 5 large modules, but the more conventional models are always 3 large modules. These parts up front, called fan blades, are responsible for moving a large mass of air behind the one responsible for 80% of the thrust that this engine gives the aircraft.
This piece here is responsible for the thrust that pushes this air out. And then part of this air enters here, which is where the air compression process begins. Okay, so let's take a look over here.
This engine model, it has 9 stages of high compression. At each stage of this, the high compressor will direct the air at the ideal angle which, at high speed, will compress the air particles until we reach the combustion stage inside the combustor.
That's right. But I wanted to look at these open compressor stages. Do we have the engine here that you can see this?
There is an engine that we are doing a repair service and we can see inside.
Let's take a look then. I'll show you what the engine compressor looks like. Let's see. This is the compressor I was talking about.
This is what we call high pressure compressor, HPC, which is the high pressure compressor.
So, the air, it comes from that front part that we saw there, and then it goes from the largest to the smallest. That is, it compresses, until it is very compressed here, and this ultra compressed air is thrown into the combustion.
And all of this is built that way. I gain pressure, and then I lose pressure and turn it into mechanical work. This engine model can reach over 1000 degrees Celsius here in the combustion area. Right after firing, 1000 degrees Celsius. Here in the compressor, we can vary between 600 and 800.
It's a high temperature too.
But it's high, too.
But it is a temperature that is like a reflection here of the combustion chamber, right?
Yes.
Well, so we've finished the compressor part here, which is the second module in the engine core. So, let's see how this part of the combustion works. Let's go back there.
With the compressor on high, it ends right at this flange here.
Yes.
Which is the last stage, and from here we have the casing, the combustion casing, and the flame. It doesn't happen directly behind that wall.
Is this piece here?
In fact, even this little piece here.
Until here, that's the combustion box.
It is inside this structure, and it has a C shape, so that it receives the fuel through the fuel nozzles, mixes the fuel and air, and it forms an ideal flame so that on the other side this gas already reaches the next stage of vanes. In the most perfect angle, let's say.
All this is calculated, just throw the air in there and wait for it to happen.
A flaw, like this, small flaws are tenths of thousandths in the calculation of gaps, of seals. The interferences. This can greatly affect engine performance. So, I brought you a removed fuel nozzle. The fuel nozzle is a fuel injector nozzle, right? You see, it is installed, that's it in that position. See how it has a shape that we can't see here on the flange? Then, this here that is inside? This here is the laying phase with the carcass. Inside, it's centered inside the combustion chamber that's going to be here around it. And, in the hole, where it is allocated, around the hole, there we have a disc, the air is coming from the compressor. They pass inside the holes. The holes, the shape of the holes displace them, and this movement of air arriving, in this way, makes them mix with the fuel that is being sprayed. Sprayed there.
And then there are the spark plugs in the combustion engine. The spark plugs in your car.
In fact, we call it a candle, too. In this engine here, we have 2. In some models we have 3, and they are only used when starting the engine and in operation with a lot of rain, with a lot of water. Other than that, they light up and then they turn off.
Because the compressed air flow itself with the fuel already generates the spark. Already keep it lit. Dude, this is interesting.
As if it were a stove, a blowtorch. Light it up and there it will keep.
Unlike the combustion engine of your car, which the spark plug, at each stroke of the engine, it gives that ignition there. Here it is, which is that noise that we hear. Ta 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 ta. The candle giving the spark.
That's right.
Okay. So, we come out of the combustor here. Next stage?
High turbine.
Of all this big business here, the turbine is actually just this little piece here.
That's it. And they are in 2 phases. Here at the high turbine, we are going to receive the gases for the blades. The rotating airfoils of the high turbine so that it can take advantage of this thermal energy as much as possible and transform it into mechanical energy. After the high turbine, we will have the low turbine that receives what is left of the high turbine. And it takes advantage of this movement to start turning, up front, our fan and our low compressor. But how is it independent? Remember I said that the high turbine shaft goes through the combustion ring?
Yes.
Inside my high shaft, I have another long shaft, thinner, that connects this lower turbine to the lower compressor and to the fan up front. After the bottom turbine, we still have the discharge section that we are not seeing here in this engine.
But we have another engine there.
Yes.
Let's take a quick look over there.
So, there we even have this flange here, see? The bottom turbine. They're all in here. Back here, it's just a structural part that we call turbine frame. I would go after the discharge, and the discharge has its ideal shape for us to discharge the gases into the environment, with as little noise as possible. And also optimizing its output, because we cannot have reflux. Reflux is bad for the health of the engine. He has to follow his speed, he has to increase this format helps. And this format also helps.
The exhaust gas here, which is this here, which is responsible for only 20% of the engine's propulsion. We practically don't see it much here. It doesn't have a very large output area, does it?
But the big thing is that this guy, this 20% that goes through here, it's what makes the other 80% become 100%. We have in our engines what we call an accessories drive module, which is made up of a gearbox. We call one the accessory gearbox, which is the box that carries the accessories, which is this one. Coupled to it, we have starter, which is like the beginning. All accessories that need mechanical movement to be activated are coupled to the gears of this accessory gearbox.
Now, just for us to finish. Here it was more or less understandable. Of course.
It has a lot of detail.
Because there are a lot of details, we are not going to go into all these details here, but I can see that there are several other things connected here. Are these pipes here, for example, connected here to the compressor? This here is the capture of air for other things that happen.
This is what we call a bleeding system, right? Basically, we have several systems connected to the engine. The only thing that is not connected to the engine, basically, is the fuel that comes from the wing. So, everything we have on the aircraft, with air pressurization, cabin pressurization, air conditioning, equipment on the aircraft itself, which are pneumatic, we bleed that from the high compressor. After he becomes self-sufficient, he has performance left over. So, we bleed his air pressure. To do this thing, the aircraft work. In addition to cooling systems for the engine itself, right?
I understood. Very cool. I mean, the engines of an airplane are really the hearts. The engines are the heart of the plane that make it all work.
Yes.
Now, one last question. Why is this engine called a reaction engine?
It is called the reaction engine because, in Newton's third law, the one that says that every force will generate a reaction of equal intensity. The big idea is, what is all this for? I throw a large mass of air backwards, and this displacement causes the motion reaction.
So, it's an action that causes a reaction, which is displacement. Very cool. Aviation, thank you very much for presenting all this, so we can show you how it works, so you can understand what the reaction engine is like. These are the parts of the reaction engine, not the turbine. You already understand why, that I wanted to show you and how it all works. And also, with Aviation's explanation, it was easy to understand. Hope you enjoyed this video. Give your like there, comment too. If you still have any questions, throw them in the comments and we'll answer them. Also, don't forget to subscribe to the channel. Thanks, and until the next video.